Assalamu alaikum, dear student. Welcome to the online class. This is your MMS sir. The topics that I should focus in today's class is basically SN1 and SN2 reaction. So at the very beginning of the class, I would like to say something about nucleophilic substitution reaction. Reaction where substitution is occurred by a nucleophile is called nucleophilic substitution reaction. So any reaction, again say any reaction, if here substitution is happened or occurred by a nucleophile, then you can say this reaction is a nucleophilic substitution reaction. Now what do you mean by nucleophile? Nucleophile is basically organic reagent which has normally attraction to nucleus. This is the first point. And second point is it should contain excess number of electron. Okay, if you consider the example of water. In water molecule, it has one oxygen atom and two hydrogen atom. Each of the oxygen atom has two lone pair of electron. So neutral molecule can also be a nucleophile. Just it should contain lone pair of electron if it is neutral molecule. Again, if any ion if it holds negative charge, it can also act as a nucleophile. Just somehow it should contain excess number of electron if it wants to be a nucleophile. So just if the substitution is happened or occurred by such type of nucleophile, then I can say this reaction is a nucleophilic substitution reaction. And this type of reaction you can denote by SN, where S means substitution and N means nucleophilic. So I can say SN means nucleophilic substitution reaction. Basically there are two types of nucleophilic substitution reaction. These are SN1 and another is SN2. So first of all, SN1. Here 1 means unimolecular, N means nucleophilic, S means substitution. So SN1 means unimolecular nucleophilic substitution reaction. Now what is the definition of this reaction? Reaction where the rate of reaction depends on the molar concentration of the reactant only. Just you consider this example. This is an SN1 reaction. But why? Because the rate of reaction, the rate of this reaction basically just depend on the only the molar concentration of this reactant, not the molar concentration of the nucleophile. Somehow if any reaction, rate of reaction if depends only the reactant but not nucleophile. Rate of reaction just depend only the molar concentration of the reactant but not the molar concentration of the nucleophile. If this is true, then you can say this reaction is a SN1 reaction, and this and for this reaction this is also this condition is fulfilled. So I can say this reaction is also example of SN1 reaction. Okay, so dear student, the reaction that you have seen on the board is basically example of SN1 reaction. Now I would like to say something about the mechanism of this SN1 reaction. You know, the mechanism of SN1 reaction is basically two-step process. First step is basically involved with the formation of carbocation, and second step is basically nucleophilic attack. Okay, so first step, formation of carbocation. In this step, carbon-chlorine bond will be broken. Here chlorine is a living group. I have written on the board. I hope you seen clearly. Chlorine is a living group. Here carbon-chlorine bond will be broken because chlorine itself is a electronegative element. Due to its electronegativity as well as the presence of methyl group here, each of the methyl group here act as the electron donating agent. As they donate electron towards this carbon atom, to break down carbon chlorine bond will be comparatively easy. Again, chlorine itself is electronegative element. Then for this reason, carbon chlorine bond will be broken and there must be produced a carbocation and a chlorine minus chloride ion as a leaving group. So the first step is basically involved with the formation of carbocation. Now the second step, after formation of carbocation, as soon as they are produced carbocation, nucleophile will be attacked here. Nucleophile will be attacked. I hope you see clearly on the board. As soon as they are produced carbocation, nucleophile will be attacked here. This is the first step. As soon as they are produced carbocation, nucleophile will be attacked and they produce the product. So this is basically the information about the mechanism of SN1 reaction. Again, I would like to mention this reaction. The mechanism of this reaction is basically two-step process. First one is formation of carbocation and second one is nucleophilic attack. In the first step, carbon chlorine bond will be broken here and there must be produced a carbocation and a leaving group chloride minus. As soon as they produce carbocation, then a nucleophile will be attacked. So and by this way there must be produced product. So I hope you understand. Now I would like to say something about the characteristics of SN1 reaction. Please try to understand me clearly. The first characteristic is basically two-step process. Two-step process. This is, I hope, don't need to discuss. You have already seen on the board. The mechanism of SN1 reaction is two-step process. I hope you understand. The second one is first order reaction. SN1 reaction is first order reaction. Now the question, what do you mean by first order reaction? The reaction where the rate of reaction is basically depend on the molar concentration of the single reactant. Again say any reaction where the rate of that reaction is basically dependent on the molar concentration of the single reactant is called first order reaction. If you consider the example of SN1 reaction, I have already told it for a number of times, and you know the molar concentration, the rate of reaction only depend on the molar concentration of the reactant. Do not depend on the nucleophile. Only the molar concentration, the rate of reaction, only the rate of reaction of the reaction depend on the molar concentration of the reactant, not the molar concentration of the nucleophile. So I can say this reaction also an example of first order reaction. Now reactivity order. The reactivity order of SN1 reaction, first 3 degree alkyl halide, then 2 degree alkyl halide, then 1 degree alkyl halide, and finally methyl chloride. So 3 degree alkyl halide is more favorable. 3 degree alkyl halide is more favorable in case of SN1 reaction. So this is why. Now this is very important question, because this is basically due to the presence of 3-methyl group in case of 3 degree alkyl halide. Again say, first step, you must have to remember this point. First step is really very important step in case of SN1 reaction. Formation of carbocation is very important step. So in case of 3 degree alkyl halide, there attach 3-methyl group with a central carbon atom, and for this reason carbon chlorine to break down carbon chlorine bond is comparatively easy. Again say, in case of SN1 reaction, in case of 3 degree alkyl halide, there attach 3-methyl group with the central carbon atom. Each of the methyl group here act as a electron donating agent. At the same time, chlorine here acts as an electronegative element. Due to the presence of electron donating agent, 3 electron donating agent, to break down the carbon chlorine bond will become more easy, and there to produce carbocation is comparatively more easy. Again, in case of 3 degree alkyl halide, they are produced 3 degree carbocation. You know 3 degree carbocation is more stable than 2 degree carbocation, than 1 degree carbocation. So in case of 3 degree alkyl halide, to break down carbon chlorine bond is comparatively easy. This is the first point. And the second point, after broken the carbon chlorine bond, they are produced 3 degree carbocation, which one is also stable than 2 degree carbocation and then 1 degree carbon. And for this reason 3 degree alkyl halide is more favorable than 2 degree, than 1 degree, or methyl halide. So I hope you understand. So this is basically the reactivity order. Now polar solvent. Polar solvent is favorable, you know. You must have to remember this point. In case of SN1 reaction, polar solvent is more favorable. Now the question, this is why. Because again, formation of carbocation is also responsible for this reason. In fact, to break down carbon chlorine bond will be more easy if you use here a polar solvent. If you use here a polar solvent, say water as a polar solvent, if you use here as a solvent, then polar solvent will there must have a reaction in between the polar solvent and this electronegative chlorine atom. If there is an interaction in between electronegative atom chlorine and water molecule, to break down carbon chlorine bond will be more easy, and by this way they easily produce a carbocation, and that's for this reason polar solvent is more favorable. Now the fifth point, weak nucleophile is favorable. Actually in this reaction the rate of reaction does not depend on anyhow on the concentration of the nucleophile. The reaction depends on the formation of carbocation, do not depend on the nucleophilic atom or second step. So if you use here weak nucleophile, it will be more easy. There you do not need to use any strong nucleophile, okay, as the reaction do not depend on the nucleophile anyhow. So there you do not need to use strong nucleophile. Again, if you use a strong nucleophile, so SN1 reaction will be converted into SN2 reaction, so there may occur problem. So that's why you should use, in case of SN1 reaction, a weak electrophile. Now does not change geometrical shape. You must have to remember this point. In case of SN1 reaction, there must not change geometrical shape. The geometrical shape of the reactant and the geometrical shape of the product will be same. There must not happen any change in reactant and geometrical shape of reactant and product. And this is a unimolecular, you know very well, unimolecular, because the rate of reaction only depend on the molar concentration of the alkyl halide, and that's why I can say this reaction is unimolecular. You know, this is basically unimolecular nucleophilic substitution reaction. So these are basically the characteristics of SN1 reaction. I hope you understand. So dear student, now SN2 reaction. Here 2 means bimolecular, N means nucleophilic, S means substitution reaction. So SN2 stands for bimolecular nucleophilic substitution reaction. Now what do you mean by SN2 reaction? So any reaction, if the rate of the reaction depends on the molar concentration of reactant and nucleophile, this reaction is called SN2 reaction. Let us consider the example that I have written on the board. If this reaction wants to be a SN2 reaction, the rate of reaction should be dependent on the molar concentration of this reactant as well as the molar concentration of this nucleophile. If this is true, then I can say this reaction is SN2 reaction. Now I would like to say something about the mechanism of this reaction. You have already seen on the board that the mechanism of SN2 reaction is basically one step process. Now what happened during the time of the mechanism of SN2 reaction? Let's see. In the case of SN2 reaction, the nucleophile should be attached to the alkyl halide from the opposite side of the leaving group chlorine atom. Again say, in case of SN2 reaction, nucleophile should be attached to the alkyl halide from the opposite side of the leaving group chlorine atom. In such a way, they are produced a transition state. Now the question is, what do you mean by transition state? Transition state is a state where carbon OH bond will be built and carbon chlorine bond will be broken at the same time. Again say transition state is basically a state where carbon OH bond will be built at the same time carbon chlorine bond will be broken. So this is basically transition state. After time being, after a little bit time, carbon OH bond will be broken completely and they are produced chlorine minus chloride ion as a leaving group, and the product will be produced. This product is called inversion product because the geometrical shape of the product and the geometrical shape of the reactant is completely opposite to each other, and that's why this the product is called inversion product. Now I would like to say something about the characteristics. The first characteristic is the reaction mechanism is basically one-step process. You have already understood this matter. Now the second point, second order reaction. As the rate of SN2 reaction is dependent both the molar concentration of the reactant as well as the molar concentration of nucleophile, so I can say all SN2 reaction are basically second order reaction. Now the third point, reactivity order. The reactivity order, the first 1 degree alkyl halide is more favorable in case of SN2 reaction than 2 degree and then 3 degree. Now the question, this is why. This is very important question. So again I would like to focus on the mechanism to understand why the reactivity order is like this. In case of 1 degree alkyl halide, when nucleophile attack from the opposite side of the alkyl halide, this is comparatively more easy because to focus this carbon atom by nucleophile, again say to focus this carbon atom by this nucleophile, when it attack it, if there presence 3 methyl group, in case of say 3 degree alkyl halide, if it is 3 degree alkyl halide, there must be present methyl group, and another methyl group is here. 3 methyl group will be present here. If 3 methyl group is present here, then to focus this carbon atom by this nucleophile will be so tough because each of the methyl group will be will act as a bulky group. So they are produce steric hindrance effect. So due to this steric hindrance effect, to focus this carbon atom by this nucleophile will be tough, and that's why 1 degree alkyl halide, in case of 1 degree alkyl halide, only one methyl group is present. On the other hand, 2 hydrogen atom is present. Each of the hydrogen atom is really very smaller atom, and for this reason nucleophile can easily focus this carbon and attack from the back side or opposite side. And which one is really so tough in case of 3 degree alkyl halide? So the factor which is basically responsible due to the reactivity order like this way, basically steric hindrance. So I hope you understand. So the steric hindrance effect in case of 1 degree alkyl halide is lower than 2 degree and then 3 degree. That's why the mechanism is like this. Now the question is, non-polar solvent is favorable. In case of SN2 reaction, non-polar solvent is favorable. You must have to remember this point because basically SN2 reaction is completely proceed through the transition state process. If you use here a polar solvent, so there must have a trouble to form a transition state or to attack nucleophile from the opposite side, or somehow there must have some there must occur some problem, and that's why polar solvent is not favorable in case of SN2 reaction. Now they are produced transition state. You have already seen this point. Strong nucleophile is needed. This is very important point. You have already seen a nucleophile should be attacked from the opposite side in case of SN2 mechanism, and so the strength of nucleophile is very important here. If a strong nucleophile, if you use here, then to attack this carbon atom will be comparatively more easy. So strong nucleophile is needed here in case of SN2 reaction. If you use here a weak electrophile here, it cannot attack this carbon atom easily. So I hope you understand this point. Now the inversion product will be produced. Inversion product will be produced. I hope you understand, because you have already seen the product, the which nucleophile should be attacked from the opposite side, or the product should be formed like this way, where which is attached from the opposite side of the leaving group. Here there was a leaving group, so the geometrical shape of product and geometrical shape of reactant is completely opposite to each other, and for this reason this product is called inversion product. So I hope you understand. So dear student, now comparison between SN1 and SN2 reaction. Okay, if you consider the characteristics, based on the characteristics, steps of reaction, you know SN1 reaction is two-step process. The reaction mechanism proceeds through the formation of carbocation. I have already discussed during the time of SN1 reaction. And SN2 reaction is basically one-step process. The reaction mechanism proceeds through the formation of TS. TS means transition state. Now the reactivity order. The reactivity order of SN1 reaction is basically first 3 degree alkyl halide, then 2 degree alkyl halide, then 1 degree alkyl halide, and finally methyl halide. In case of SN2 reaction, the reactivity order is basically firstly methyl halide is more favorable, than 1 degree, then 2 degree, and then 3 degree. Now the rate of reaction. Rate of reaction depends on the molar concentration of the reactant only. I have already said these topics for a number of times. The rate of reaction is basically depend on the molar concentration of reactant only. In case of SN2 reaction, do not depend on the molar concentration of nucleophile. But in case of SN2 reaction, the rate of reaction depends on the molar concentration of the reactant as well as the molar concentration of nucleophile. And that's why SN1 reaction, they are basically first order reaction. This is basically second order reaction. Now nature of solvent. Polar solvent is more favorable. You know, in case of SN2 reaction, SN1 reaction, in case of SN1 reaction, polar solvent is more favorable. In case of SN2 reaction, non-polar solvent is more favorable. Now nature of nucleophile. In case of SN1 reaction, weak nucleophile is favorable. You do not need to use here strong nucleophile in case of SN1 reaction. If you use only weak nucleophile here, this reaction you can proceed. In case of SN2 reaction, you must have to use here a strong nucleophile. Again say, in case of SN2 reaction, you must have to use a strong nucleophile. Now the geometrical shape in case of SN1 reaction, the geometrical shape of the product will remain same just like as the geometrical shape of the reactant. But in case of SN2 reaction, the geometrical shape of the product is completely opposite to the geometrical shape of the reactant, opposite inversion product, that's why it's produced, you know. So this is basically the comparison in between the SN1 and SN2 reaction.